Hello, everyone, and welcome back to the show Beyond the Business. Today, we continue with the second episode of my Waste Saga podcast documentaries. Sometimes the loudest story is the one everyone tries not to talk about. When we speak about green energy, we are used to hear only one half of the truth, the polished and inspiring, beautiful version. But there is another half, the part that rarely makes it into presentations. Today, we are going to talk about that side, the part that's left behind after green technologies finish their job, the part nobody puts on stage at the climate summits, the part that does not fit into simple promotional slogans. This is a story about the energy of the future and the waste the future quietly leaves behind. The energy of waste. We call it clean energy, but the truth is more simple and impossible to ignore. The energy is renewable, the materials required to harvest it are not. Wind turbines, solar panels, and large scale batteries became symbols of progress. But look at the ground beneath those symbols, and you will find the reality far less glamorous. We live in a world where wind turbines tower over fields like monuments of hope, where solar farms stretch across deserts like a glittering promises, and where massive battery arrays sit quietly in high tech boxes, storing tomorrow's ambition. But eventually, every blade stops spinning, every panel stops producing, every battery reaches the end of its cycle. And when that happens, what then? People rarely ask this question not because it's unimportant, but because it's inconvenient. Because the truth is, green energy has an afterlife, and that afterlife is anything but clean. A wind turbine blade is a composite made of epoxy resin and fiberglass. It cannot return into any closed loop. Europe operates around 290 GV of renewable wind capacity today, and nearly 80 will reach end of life by 2030. The industry expects up to 55,000 tons of discarded blades every year within this decade. Most will be buried because they cannot be recycled, and isn't theory. It's already happened. In the Casper Regional Landfill in Wyoming, bulldozers carve trenches as long as football fields to bury blades because no scalable recycling exists. In Iowa, hundreds of retired blades were stacked in open fields, then chopped into sections like industrial carcasses before being hauled to landfills. Local communities were stunned. Nobody told them that clean energy could leave behind this much waste. In Germany, decommissioned blades accumulate in storage depots, enormous curved structures stacked like stranded whales. Municipalities struggle to find contractors willing to take them because disposable costs are high, recycling options limited, and the volumes keep growing. Some regions have openly admitted they don't know what to do with them as piles continue to rise. And companies like Siemens Gamesa, despite technological leadership, face the same reality. The older fiberglass blades cannot be recycled at scale. Many end up buried or stored indefinitely. Clean energy above ground, industrial waste below it. Wind turbine blades are one of the biggest blind spots of the renewable energy transition. They have been presented as symbols of clean energy, yet most of them become long lasting composite waste that cannot be recycled through any conventional process. So here's the real picture. Fact 1. Recyclable blades already exist. Recyclable blade technologies are not theoretical, they exist today. Thermoplastic blades. These blades can be melted and reprocessed, allowing true material recovery. Dissolvable epoxy systems demonstrated a chemical process that breaks down hardened epoxy previously considered impossible, allowing resin and fibers to be separated and recycled. Fully circular composite prototypes. Tested blade prototypes made from redesigned composite systems intended for full circularity, including repolymerization and remanufacturing. These technologies prove that blade recycling is technically achievable. Fact 2. Traditional blades are designed as non recyclable. A standard wind turbine blade is made from glass fiber, epoxy resin, balsa wood, fillers, carbon fiber reinforcement. This contamination creates a rigid, durable composite that cannot be separated once cured. It was never designed with end of life in mind. Why these solutions are not implemented? The barrier is not technology, it is economics. And reason 1. Recyclable materials are more expensive. Thermoplastics and advanced epoxy systems cost more and require new production lines. Reason 2. Wind turbine margins are extremely thin. Developers are locked in price per megawatt. Any increase in blade cost threatens contract viability. Reason 3. The supply chain is fragmented. Manufacturers build the blades, developers operate the farms, and the third parties handle disposal. No single actor is responsible for end of life waste, so no one has an incentive to redesign the system. Reason 4. The renewable narrative cannot tolerate negative waste topics. Institutions like IRENA, ICLA, and COP platforms avoid discussing the waste footprint because it undermines the clean energy message. As a result, political pressure for redesign is weak. So, the consequence: it is cheaper today to produce waste than to produce solutions because the industry prioritizes lower cost manufacturing. The system continues to create non recyclable composite waste at scale. Blades are landfilled, buried, or downcycled into low value materials. By the time recycling becomes mandatory, dealing with accumulated waste will be more expensive than redesigning the materials today. So the technology to recycle blades exists, the industry simply refuses to adopt it because the current economic model rewards waste, not circularity. Cheap production today guarantees expensive environmental and financial consequences tomorrow. Wind energy is not limited by engineering, it is limited by design choices made for cost, not for sustainability. So let's talk about the solar panels. Solar panels carry their own hidden story. Glass and aluminum sit on top of polymers, adhesives, silver, lead, and cadmium. They don't separate cleanly, they don't cycle. Global forecasts predict 54 to 160 million tons of PV waste by 2050, all created by technologies marketed as the future of sustainability. In California, piles of discarded panels will storage yards, like solar waste mountains. Some call them a waiting processing that never comes. Many recycling centers refuse them because the toxic components make them too expensive to dismantle safely. But the problem isn't American. In France, thousands of aging panels from early feed and tariff projects now sit in temporary depots because certified recyclers are overloaded, cannot keep them. In India, for example, retired PV modules are often stockpiled in warehouses with no regulatory oversight, with reports of panels being illegally dumped in open landfills. We built a blooming solar industry. We did not build a plan for its retirement. Solar panels are one of the most underestimated waste challenges in the renewable transition. They are promoted as symbols of clean, limitless sunlight, yet most those models become chemically bonded just waste that cannot be recycled into new panels. Here's the real picture. Fact 1. Industrial solar recycling exists, but not at scale. Recycling technologies for PV modules are real and proven. High temperature delamination in Europe and Japan, burns of encapsulants enabling recovery of silicon, copper, and metals, chemical solvent separation, dissolves EVA layers to extract silver, silicon, and copper, laser delamination, separates layers without breaking the glass. These technologies show that true PV recycling is technically possible. Fact 2. Panels were never designed to be recycled. A standard solar panel is permanently fused from glass plus EVA polymer plus silicon plus silver copper plus aluminum frame plus backsheet polymers. Once laminated, these layers cannot be separated economically. They were engineered for durability, not circularity. Why these solutions are not implemented? The barrier is not science, it is economics and system design. Reason 1. Recycling is more expensive than landfilling. Recycling a panel costs about $10 to $30. Landfilling costs from $1 to $3. Reason 2. Toxic backsheet layers complicate recycling. Those layers release toxic fluorine compounds when hidden. Reason 3. No producer responsibility. Manufacturers, EPC contractors, and solar farm operators are separate actors. No one owns end of life obligations. Reason 4. Waste narrative is avoided. Consequence. It is cheaper to create solar waste than to recycle it. Most countries landfill solar panels, others stockpile them. Some export them to regions with weak environmental controls. The accumulated waste will cost far more to process later than redesigning panels today. So the core problem is recycling technology exists, the industry refuses to adopt it because low cost installation is prioritized over life cycle responsibility. Cheap solar today means extremely expensive toxic waste tomorrow. Solar energy is not limited by engineering, it is limited by design choices made for cost, not sustainability. And here comes the battery problem that nobody wants to own. Large batteries complete the picture. By 2030, end of life lithium ion batteries from EVs and stationary storage are expected to reach several million tons per year globally, with tens of millions of tons accumulated by mid century. Even under optimistic scenarios, recycling recovers only part of the lithium, nickel, cobalt, and manganese. A true closed loop does not exist, only a slowly shrinking one. Behind every electric car, every home, storage system, and every grid scale battery farm lies a mixture of flammable, reactive, toxic materials that green energy marketing rarely likes to talk about. You've heard success stories about recycling, but there is the other side. Tesla Gigafactory were caught improperly storing hazardous battery waste outdoors, leaking chemicals into the soil. Across the US, recycling companies have been discovered simply hoarding used batteries in abandoned warehouses. Some sites have burned to the ground after spontaneous ignition. And beyond the US, the picture isn't cleaner. In South Korea, one of the world's largest battery producers had to shut down a storage site after inspectors found thousands of tons of used EV cells piled unsafely. A fire risk so severe that the government ordered urgent removal. In China, informal scrapyards disassemble EV batteries by hand with acid spills, fires, and airborne toxins as a routine byproduct. Most batteries are not recycled. They are stored, abandoned, or dumped. Large batteries are the most hazardous blind spot of the green transition. They are promoted as enablers of decarbonization, Yet most become flammable, chemically reactive waste that is not truly recyclable. And here is the real picture. Fact 1: battery recycling technologies exist. Industrial processes include hydrometallurgical recovery, chemical leaching to extract cobalt, nickel, and lithium, pyrometallurgical smelting, burns of plastics, electrolytes to recover metals, direct cathode recycling, restores cathode material for reuse. These methods prove battery recycling is technically feasible. Fact 2: modern batteries are not designed to be recycled. Battery pack is a structural fortress. Cells, modules, thermal barriers, adhesives, welded bus bars, resins, housings, BMS electronics. They are glued, welded, potted, and sealed intentionally. This assembly is dangerous, slow, and expensive. Why these solutions are not implemented? Not engineering, economics. Reason 1: recycling costs more than new mining. Fresh lithium is often cheaper than recovered lithium. Reason 2: manual risky disassembly, automation is hazardous, humans must dismantle packs. Reason 3: low cobalt chemistries reduce value. LFP batteries offer almost no economic incentive for recycling. Reason 4: no unified responsibility. Automakers, energy companies, and recycle operate independently. Reason 5: waste narrative is suppressed. Hazardous waste conflicts with government EV deployment targets. Consequence: hazardous waste accumulates faster than recycling capacity. Battery stockpiles grow globally. Many are abandoned, hoarded, or dumped. Fires are frequent. Regulation is far behind. The core problem: recycling technology exists, but the industry is built around manufacturing volume, not circular design. Cheap batteries today guarantee extremely expensive hazardous waste tomorrow. Battery technology is not limited by engineering, it is limited by economic and policy decisions that ignore end of life responsibility. The shadow footprint. Every green technology has two footprints: the visible one, the clean, public, PR polished footprint, and the shadow one, the footprint that begins only after the product dies. Recycling promises often sound impressive until you look at the fine print. Up to 95% recyclable often means in laboratory conditions. Circular materials often means we recycle the metal frame but bury the rest. Low carbon footprint manufacturing often means high carbon footprint disposal. The shadow footprint is everything that happens after the camera cuts, after the ribbon is cut, at the inauguration of a new green energy facility, and after the journalists go home. It's the part nobody shows, and it's the cost that nobody includes in the brochure. So, who is responsible? That is the uncomfortable question becomes, and here is the answer. If government approve these technologies, subsidize them, and accelerate their deployment, so who is responsible for the waste they create? Right now, responsibility is a foggy space. Governments authorize wind farms, solar farms, battery infrastructure, but rarely require end of life plans. Companies promote the sustainability of their products but remain silent about disposal. National recycling laws lag 10, 20 years behind the growth of renewable installations. And in many cases, both regulators and producers rely on landfills as the temporary solution to a permanent problem. We are building a clean future on top of the waste we don't want to acknowledge. So, why this matters now? And it does matter. Green energy is not the enemy, it's necessary, essential, unavoidable. The planet needs it. But what the planet also needs is honesty. A wind turbine that generates clean electricity but leaves behind 60 tons of unrecyclable waste is not green. A solar panel that reduces emission by ants leaking cadmium in the landfill is not a clean solution. It's a delayed problem. A battery that enables decarbonization but becomes hazardous waste 5 years later is not clean innovation. It's innovation with a blind spot. If we want a sustainable future, we can't only optimize the front end, we must confront the back end. Here is the paradox. We are accelerating the deployment of green energy faster than we are building systems to handle its waste. It's like inventing airplanes before inventing runways, like encouraging everyone to buy cars before building roads, like building skyscrapers before designing elevators. We are creating a massive industrial ecosystem with no life cycle plan, and the longer we wait, the bigger the shadow footprint becomes. The solution isn't to stop building green energy, the solution is stop pretending that the waste doesn't exist. We need regulations that require full life cycle plans, real recycling technology, transparency about renewable waste, corporate responsibility, a shift from build fast to build smart. Governments must not only approve projects, they must approve the cleanup plan. Companies must not only innovate products, they must innovate their afterlife. Clean is not a default setting, it's a responsibility. So here we are, standing between two futures. One future shines, the other quietly piles up in landfills, warehouses, deserts, and abandoned lots. The question isn't whether green energy is the right direction. It is. The question whether we are willing to face the full truth, not just the part that looks good on stage. Because the future will be powered by green energy. But whether it's buried under its waste, that part is still up to us. Thank you for listening and see you in the next episode.